Okay, so recording is triggered. Welcome everybody to this week's Gardener review meeting. Today we look at the 140 release and we have 4 topics. We start with Radoslav with the new feature gate for removing Vali. Then I will talk about optimization in the network policy controller. And then we have 2 topics related to GAP28, the self-hosted shoot clusters. The first one is presented by Johannes about direct access in the local setup. And the second one, some update about the controller story in gardenlet and the extension management by Toby. Okay, then let's get started, Radu, with the first topic.
Thank you, Rafael. Good morning, everyone. I'll be very quick. Now this RemoveVali feature gate is part of the GAP35 story, where we are migrating from Vali to VictoriaVox. In a previous review meeting, I showed the VictoriaVox backend feature gate, which actually deploys an instance of VictoriaVox. And now this new feature gate RemoveVali, well, it removes Vali. What I would like to show you is basically the sequence of enablements of the feature gates. So what you see now is the basic OpenTelemetry setup for a specific shoot cluster. So we have the shoot cluster itself, all the nodes via OTOP, they send logs to an instance of OpenTelemetry collector in the shoot namespace. And then the fluent bits on the seed clusters, they send the control plane logs to the same OpenTelemetry collector instance, and that instance sends logs to the Vali instance. Well, when the VictoriaVox backend feature gate is enabled on the gardenlet, what simply happens is the only thing that changes is that now the OpenTelemetry collector, when it receives logs from either FluentBit or the OpenTelemetry collectors on the shoot nodes, it sends the signals to both the VictoriaVox backend and Vali. And RemoveVali, you're not going to guess what happens when you enable RemoveVali. Well, Vali just gets removed. Now, the reason for why we have this two-step migration is because operators would like, there's a possible use case, and it's a perfectly normal use case, where operators of landscapes would like for there to be a migration period from Vali to VictoriaVox. So for example, you enable VictoriaVox as a backend, it starts receiving logs from the collector alongside the Vali instance. And then when you're sure that both backends, so both VictoriaVox and Vali, have the same signals aggregated on their side, well, then you can optionally, whenever it's appropriate, enable the RemoveVali feature gate, and then VictoriaVox will be the only backend left. Now, the only thing I would like to mention is that these feature gates can be used, but I would personally hold out a couple of weeks on enabling them, since there's still some work that has to be done regarding the visualization of the logs. So Plutono is basically a dashboard that we've used so far for visualizing logs from Vali. Well, during the period where we're using, from now on, when we start using VictoriaVox, we'll be using VictoriaUI until we land on the appropriate next solution, which should be Persis. Well, VictoriaUI still doesn't have an ingress, and it's not shown in the dashboard, so it's not that easy to open it. And in the next weeks, that will be done. And yeah, that's about it. There's no demo, since the demo would be showing you how Vali exists as a pod, and then Vali does not exist as a pod after the feature gate. This is the more interesting part of the whole architecture. of the logging stack. If there aren't any questions, Rafael, I think you were after me.
Yeah. Before we continue, any questions for the RemoveVali topic? Nope. All right. Then I will continue with the next topic, which is the network controller optimization. So this is about this pull request. And I think it's best if we directly jump into the system and check it out there. So I have created a local setup for the demo purposes, just a simple make kind of gardener app. And this has one seed, just two extensions, and I created one shoot cluster here. So this is based on the old version, 1.139, which doesn't have this PR. And if we list all the network policies in this cluster and count them, then there are quite a lot for just a simple local setup with one shoot. So 570 network policies is quite a number. And especially if you now scale this up to 200, 300 or more control planes on this seed, this can easily go into a 6-digit number. And yeah, most of these policies are actually unused. So the controller that was already created a couple of years back is watching all the services in the cluster. So for each service, it checks which are the ports that are exposed, and then creates 2 network policies for each port, so that pods can easily use labels if they want to communicate with a certain other pod. So with this, there is no need to manage custom network policies or whatsoever. You just need to label your pod with the expected format, and then traffic would be allowed to your destination. Okay, but as said, most of these policies are unused. And what we have implemented here in this PR is that we adapted this controller to also watch pods. So we can maybe quickly check the code just on a high level. So here's the controller, the main resource, and also what it mainly reconciles are services, as already mentioned. It already had 2 more watches for network policies and for namespaces. And now we added another watch for the pods. And this enables it to check if there is actually a pod that needs the network policy that it attempts to create. And only if it's really needed, then it really creates these policies. Okay, so let's update the Gardener Resource Manager, which runs this controller, to the new version. So this is an image built from the master branch, which has this pull request. Here we are watching the network policies, and you already see it's dramatically going down now that the new resource manager was rolled out. So we reduced by more than a half. And now actually only the policies that are really needed by the pods are remaining in the system. So how does this work now with new pods? Let's take a look at the services here. In the shoot namespace, there's, for example, this VPA recommender service, which has only 1 port. And I think nobody is talking to it from the regular control plane pods. So this is one policy that got deleted now. But let's say we introduce something new and now we suddenly need to communicate with it. That means we need something like this. We need a pod that is labeled with this label, networking and so on, to VPA recommender, which is the service name, then the protocol, and then the port that we actually want to talk to. As said, currently there is no such pod and hence also no network policy. So now let's just create a dummy busybox pod with exactly this label. And you can watch here, when we create this pod, we should see the policies increasing. So it jumped to from 21 to 23, 2 more policies. And if we get the relevant network policies for VPA recommender, we see that this one is newly created. This one is newly created. This already existed before, so this is for scraping from the garden namespace, but this one is for direct communication from the shoot namespace. And this is now needed because there's this busybox pod that we just added. We can also delete the pod again and watch this. The deletion takes a bit longer because the pod needs to be terminated. But after the pod is fully gone, we should also see that this goes down again to the 221 that we had before. Yeah, it takes a while. While we wait, maybe I can show some pictures from real landscapes so that you get an impression, how it worked, of the impact of this. So I think this is the first one. Here we have rolled this out on a dev landscape of ours with a not so heavily utilized seed. But still, you can see that before the change, it had almost 100K network policies. And then we rolled this change out, and now it's down to 12.5K. So it's, yeah, of course, the more shoots you have in a seed, the bigger the effect is. So in this local setup where we just have one shoot, it's just like 60% or something like this. But yeah, if you have more shoots, of course, which are the main contributor to the network policies, this is even more relevant. Here is a screenshot. We haven't rolled out this change here yet of one of a very big seed cluster. I don't know, 250 or more control planes. You see it sometimes goes up to even 180K network policies. So when we roll out this change, we would expect this to go down to like, I don't know, 20K or something. Okay, yeah. I think that's all about the change. If you have any questions, feel free.
Just a quick question. Do you expect some disruptions upon, I don't know, initial running of pods? Say, for example, when they get scheduled, start up until the network policy is created, if that happens to be a little bit later?
Yes, of course, if the controller is down and cannot create the policy, then the pod would be blocked from communication. But since Gardener Resource Manager is a very critical component that has even pod creation webhooks in the first place, probably the pod wouldn't even come up when it's down. So maybe a theoretical concern only.
Okay.
Okay, then I think we can continue with Johannes and get 28 direct access of self-hosted shoots.
Okay, hello also from my side. I hope you can hear me and see my screen. I am presenting this change here about making the self-hosted shoot API server accessible from the host machine in the local development setup. So basically, let's dive into it. I have a local setup running here. I have also created a garden inside the kind cluster where also my local setup is running. I have created the self-hosted shoot cluster, so I'm here in the top right, connected or exec into the node that has a self-hosted shoot cluster. So we can see basically the self-hosted shoot cluster with garden ADM in it is running. And we also see basically the corresponding pods. Everything is nice. In the past, that was the easiest way to interact with the self-hosted shoot clusters, meaning you could exec into the machine and then directly work on the self-hosted shoot cluster with it. The a little less convenient way was if you wanted to go from the hosting machine, so your actual laptop or VM, into the self-hosted client cluster, then you would need to port forward into the corresponding pod and get corresponding kubeconfig. And now with this change, this gets easier. So I will show you. I will not show you the before part with port forward, because I mean we know how port forward works, not a big deal. But now we basically just need to run this generate admin kubeconfig local script with the parameter self-hosted shoot. Once we do that, we basically see that we get a kubeconfig. We can just put it into a local file on our host. And once we've done that and export the kubeconfig environment variable to the corresponding kubeconfig, we can do basically the same thing that we did before. We can get the pods or the namespaces. Okay. Here I don't have the context set. So that's basically the same thing I did before, but now I can do that from my local machine, which is much more convenient than it was before. And as part of this, so if you're working with self-hosted shoot clusters in the local development setup, that's obviously a nice improvement. But as part of that, we also changed the generation for the garden cluster of the kubeconfig. So basically, as said, I have created also generated a garden inside the same kind cluster. So you see the garden resource was created. It's successfully reconciled. And now I can also, with the same script, but with this different parameter, virtual garden instead of self-hosted shoot, I can also get basically a kubeconfig. I can put that again into a file. And when I export it, I can once again access my virtual garden in the same way I could previously in the non-operator setup directly access the garden cluster. Yeah, that's basically it. It makes a lot of things much more convenient in the local development setup for self-hosted shoot clusters, but also combines basically the generation of the admin kube configs for virtual garden as well as self-hosted shoot clusters. So with that, any question? Or otherwise, I would hand over to Toby.
Right, if there are no further questions, then I will take over. Okay, so yeah, I want to talk a bit about what happened in the last couple of weeks, also in the self-hosted shoot cluster corner, but yeah, now in the Garden IDM Connect case. So what happened with the gardenlet in the self-hosted shoot case? And yeah, as you can see, almost all controllers were now enabled to also work in the self-hosted shoot case, except the shoot controller, which is still something that needs to be done. But yeah, what also is a big milestone, I suppose, is the extension management that also works now for the self-hosted shoots, which means that yeah, controller installations will also be created when the self-hosted shoot gets connected to a garden during Garden ADM Connect. And before I show you the demo, I want to show you a bit how the demo setup looks now in the unmanaged infra case. So for example, there's now a method to run the virtual garden or the operator and then the garden inside of the self-hosted shoot that you bootstrap. So basically the local kind cluster, there are in the unmanaged case just basically some machines acting as VMs, so to say. And with Garden ADM init, yeah, you can get your self-hosted shoot. You can join workers with Garden ADM join. And yeah, when you use Garden ADM app scenario connect by default, it will try to bootstrap this virtual garden, so the operator and the garden resource inside of the self-hosted shoot. And now you can, with Garden ADM Connect, you can connect this self-hosted shoot to the garden that runs inside of this self-hosted shoot. Yeah, that sounds a bit overwhelming perhaps, but yeah, this is now how it is. Yeah, so let's see how this actually looks like. So for example, I've also have this virtual garden, and if we look at the shoot, we see that because of the gardenlet now taking care of, for example, the conditions, we see that the API is running and the conditions are maintained. But for self-hosted shoots, there are also two additional conditions, namely the gardenlet ready condition and the backup buckets ready condition that yeah, give operators a bit more overview about stuff. And as you can see, not everything, all health checks pass yet. For example, yeah, for observability, etc., we don't deploy it yet. So this is something that is that the checks themselves are, yeah, failing rightfully, so to say. Yeah. So if we now look at the controller installations inside of the virtual garden, you see, for example, networking Calico and the provider local. But these are not referenced or installed on a seed, so to say, but referenced through a shoot. So if we now look, for example, at networking Calico, we see that there is now not a seed ref, but a shoot ref. And yeah, this is basically part of this extension story to also avoid duplicate installation when this self-hosted shoot would get promoted to a seed. So you could also install a gardenlet in the garden namespace on there, and then the self-hosted shoot would also become a seed. And then it's basically everything. It's a runtime cluster, it's a seed, and it's a shoot. And yeah, so this is basic, so we don't duplicate installations. What also this means is that, oops, the namespaces for the extensions, they don't get the suffix in this case, so that this also does not clash. Yeah, that's about it in a nutshell. So if you have any questions, let me know. Otherwise, that would be it from my side, and I would get back to Raphael.
Yep. Okay. Seems there are no questions. Jan, is this a question or wrong
Yes,
button?
that's a question.
Ah, nice.
Just out of curiosity, how long does it actually take to set up this virtual? Sorry, is it now shoot or seed?
I mean, it is everything, right? But so for this local setup with unmanaged infra, so I've booted myself. I've written myself a small script that does everything, so that you get to the point which I just showed you. And I think this took 20 minutes. There's some ways to probably speed up it, because I do everything sequentially, but I think something around that time. I don't know if someone wants to correct me.
Yeah, that would be very lovely, because we in the Garden Linux sometimes have the problem testing shoots or seeds, depending on the situation. And I would be really interested integrating that in our testing pipeline. So where we can chat later on. I mean, nothing we can do today or tomorrow, but like in the long run, that would be very lovely.
Yeah, sure, I guess. But I think the local setup right now with like make kind up garden up, I think this might be still a bit faster as of today. But yeah, I mean, we can try it out. We can talk about it. Happy to help.
All right. Cool. Then I guess that's it. This was the final topic for today. Then we can close the meeting and see us again in 2 weeks for the next occurrence. Thanks everybody for joining. Have a nice time. Bye-bye.
Thank you very much.
Bye.
Bye-bye.
Bye.
Thank you. Bye-bye.
Bye.